All right, so welcome everybody to another video for StatPowers. This one is for a new portion of the website. At least it's new at the time of this recording. This is very, I guess we could call it basic survival analysis. So it's survival data. We're going to I'm going to start to simplify this a little bit. I'm going to change the number of groups to just one. We're only going to look at one sample of survival data. And survival data is basically just the length of time that each individual in our sample quote unquote survived. So, or the time until some particular event occurred. An event could be anything. It doesn't have to be death. It could be the time until a popcorn kernel popped. It could be the time until like a person gets a phone call from a robocaller, or I don't know, any sort of event. And you could even have individuals asynchronously kind of observed. But for our purposes, we're really recording two pieces of information per individual. We're recording how long they were observed, and whether their observation ended with the event occurring or not. And to indicate that the event did not occur by the time the observation ended, we add a little plus. So, for example, let's say I have let's say we're observing a whole bunch of people and seeing during the course of some amount of time, and we're observing whether or not they what's something that isn't so lethal? Let's say observing whether or not they got a cold. How about that? Okay, so let's say one person 5 days before they got a cold. The next person 12 days before they got a cold. Another person lasted 16 days, they got a cold. There was somebody who lasted 1 day and they got a cold. We had somebody who was 17 days. We had 15. We had somebody that was, let's say, 10 days, and then they dropped out of the study. And so we don't know whether they got a cold or not. We would say 10, and then we put a plus. And then 9 plus, and let's put a large number, 25. Okay, and let's end it with maybe somebody who was observed for a full 30 days and then they never got a cold. So, I'll name this got a cold, and we're measuring it in days. That's the default value, but at the moment I have to type that in. So yeah, click. I can look at a couple of things really. For one sample, I can look at summary statistics. It's just going to tell you how many were in the sample, how many were censored, and how many were failed. Or the failure is like the event happening. So if it was death, that would be a failure. The total for the group. That's just to give you some quick proportions. The average survival time is calculated for you. So that 14 days is the average, and then that's ignoring what we call the censored data. Censored are the ones where the event didn't occur during the time of observation. There's distinguished in the literature. We distinguish between left censored and right censored. Left censored generally being that they the observation didn't begin at the same time as the others. Like they had a staggered entry into our study, like they came into the study, a little bit while after. And right censored would be that we stopped observing them and the event hadn't occurred yet. But for our purposes, censored is censored. This is kind of standard notation. So we have the average survival time, the median survival time, so that would be like the 50th percentile, and then the average hazard rate, which is it's calculated as the number of failures over the total amount of time. So this is an average rate of the number of failures per day. That's per participant day. So like basically every individual in the study had like a 5% chance of getting a cold each day. All right, the survival function is a way of charting this, and it's going to look like so. You have over time, it's going to give the proportion or probability of individuals surviving that long without getting the event, or without the event occurring. So here we've got you can see the survival curve always starts at 1 and goes down. In this case, because we ended with a censored data, we have the last individual not bringing this curve down to 0. And you'll see little tick marks along this function for representing individuals being censored. The survival function is you can show confidence bounds. These are 95% confidence bounds, and they're approximate. They're using a formulation for these are using a formulation. I think Green's a formulation, but it may not be super useful. Now, things get a little more interesting when we have two data sets, like 2 sample groups. So what I'm going to do is I'm going to increase my number of groups to 2 groups, and I'm going to paste in some more data. So what I've got here is just some pasted data. This is the remission times of leukemia patients in weeks. We have a treatment group and we have a placebo group. And so what we have here, you can see that we have some censored data in our treatment group, and we don't have any censored data in the placebo group. There was remission for all of these in the placebo group, but not all for the treatment group. Now we can look and see the statistics are given for both of these groups. That's fine. Now let's take a look at the survival functions. You can see that there's a big difference between the two, the red being the treatment and the blue being the placebo. The remission, it was a lot more time in general for remission on the treatment group than on the placebo group. You can see that, like say over, you can see at 6 days, we still hadn't had any remission, or 6 weeks, sorry, in the treatment group, and in the placebo there was already, and it looked like only 80% of the patients remained, and so forth. You can see you can compare 2 curves. So this is just basic comparison of the survival functions. The confidence bounds can get a little bit they tend to overlap a lot. When they overlap, what that can indicate to you is that there is not a significant difference in survival time for the probability of survival at those times. So it looks like at 7 weeks, just based on this data, there wasn't a significant difference in survival time between the two. But it looks like that was only the case for a small period of time. It looked like from 7 to 11 or 6 to 11 weeks. Okay, so you can compare 2 survival functions, and then we have hypothesis testing. Let's close the data and take a look at the 2 kinds of tests we have. Is a survival function z-test, which allows you to test whether the 2 survival functions are significantly different at a certain time. And so what you can do is put in a different time. If I was interested in checking at 8 weeks, is the survival significantly different between the 2 groups, you just put in 8, and it looks like at 8 weeks, actually, still the survival functions are significantly different. The p-value is low. It looks like if I put whatever values I'm putting in, actually, at 7 weeks, they're not significantly different, but that's pretty close to the edge. It was really 7 weeks, and then Yeah, and even that's like pretty much the only time when they overlap enough that it's not a significant difference. If you had more than two groups, you could choose which two groups you want to do a like a pairwise test of. But for now, we just have one group or two groups to look at, and that's fine. The other test is a log rank test, which it is going to test the entire survival function from start to finish, and it will tell you whether or not the two survival functions are significantly different from each other, taking the entire time range into account. Log rank test is it's right here. It's pretty simple. If you had more than two groups, you could choose which is going to be in your null hypothesis. But for us, we have only one. It gives you a chi-square statistic and a p-value, a critical. It gives you a critical chi-square. If your chi-square statistic is larger than your chi-square, your critical chi-square, then that means your data suggests strong evidence that your survival functions are different. And that's it. It'll give, of course, give you a p-value, which is going to be your quick check to see whether or not they're significantly different. So this is survival function analysis basics in a nutshell in StatPowers. There's not a ton that we do. Basically, we're just looking at the survival functions and there's a few little statistics we can calculate, and then hypothesis testing of whether the two survival functions are significantly different or not. And that's it. So hope you enjoy, and I hope that you find this useful in your academic career and beyond. All right, take care. Bye.